The product rule, which after you do a couple hundred of these, you'll know because it's not on your formula sheet. So there's some rules you must know. This is one. So let's say we have two functions, f of x, which is 2x plus 1, and g of x, which is x squared minus 4. Determine, it's really almost kind of state, I guess. But yeah, what's f prime of x? Equals 2. What's g prime of x? 2x. What's f prime of x times g prime of x? Yeah, so it's going to be 2 times 2x, which is 4x. What's f times g of x mean? It's f of x times g of x, right?
So it's 2x plus 1.
Yeah, so notation, this stuff you did last semester or last year, right? So f times g of x means we take f of x times g of x, which is 2x plus 1 times x squared minus 4. So in decreasing order of degree, what are we going to get? 2x cubed and a 1x squared and a minus 8x and a minus 4. Right? It's a little unfoily thing. So I think I did file, not foil. What is f times g prime of x? Or in other words, what's the derivative of this?
6x squared.
6x squared
Plus 2x.
plus 2x
Minus 8.
minus 8. So is this equal to this? No. All right. So we have learned what not to do. Product rule, the product. So how do we handle this? How do we find the derivative of a product? So if f and g are differentiable, then so is the product, fg. And fg prime of x is equal to f of x, so just think the first function, times g prime of x times the derivative of the second function, plus g of x, the second function, times the derivative of the first. Okay, so you take the first function, write it down, multiply it by the derivative of the second function, right? Because you got a product, so you got two things multiplied. Plus, then take the second function, write it down, and do the times the derivative of the first. Now, being as it's adding, it really doesn't matter what order you do it in, right? Addition is commutative, so you could do the second function, you know, whatever. In Leibniz notation, we have d by dx of f of x times g of x is equal to f of x times d by dx of g of x. So the first function times the derivative of the second, plus g of x times d by dx f of x. Now I learned it, or what I remember is we did differentials slightly different. You do d of uv was u dv plus v du. Either way, so it's the first function times the derivative of the second function plus the second function times the derivative of the first. Or, okay, I think I just said that. Yeah. Use question 1 to verify the product rule. Okay, so we're looking at question 1. Well, you are. It's on your same sheet. Okay, so what are we saying? F G prime of x is equal to, so you know what, write the formula down, because after you've written it down like 50 or 60 times, you'll remember it, or you'll remember it better. So every time you do it, just write it down. Okay, because you have to memorize it. Right? So every time you do it, write this formula down. All right, so f of x was what? 2x plus 1, right? So 2x plus 1. And g prime of x, so we worked this all out, everything's worked out up top. So what's g prime of x? 2x. Plus g of x. What's g of x? It's x squared minus 4 times f prime of x, which was 2. It says Spock died. I'm guessing by that he means Leonard Nimoy must have passed away.
Wow.
You heard it here first.
Is that why the bells chime? Oh my god.
What?
Was that sound because of the notification or because he died?
The sound is my text sound, so that was, and then I read it on my watch.
Oh, so it was a friend of yours who texted
It was a
you.
daughter of mine.
Ah!
Who, yeah, I guess I
Are-
consider
yeah.
her somewhat of a friend.
Yeah, that's.
She's old enough now to be a friend. I don't know, so I want to verify that. Go on Twitter, quick. Leonard Nimoy should be trending, right? Or Spock. All right, so what do we have here? So we have 2x, let's do it this way. 2x times 2x plus 1 is going to be 4x squared plus 2x plus 2x squared minus 8x. So what do we got? 6x squared.
Right?
Oh, minus 8. Yeah, not 8x, right? So 6x squared plus 2x minus 8.
Whoa!
Which is what?
A quadratic
It's the derivative of, where did it go?
Oh my god.
At the top. Holy schnitzel.
That's the top.
Sorry.
It's this.
Oh my god.
Okay. Check. Hey, works. Right? Example 2. Determine. I think there's a proof in the book of the product rule if you wanted to look that up, right? You could.
I trust you.
Yeah, and so that works. I mean, you would basically just do the thing in general, right? Going back to first principles. Determine.
Who else could die now?
No, it's just a repeat. You know how texts, if you don't look at them, just repeat themselves.
Back to life.
Yeah. Well, I guess it's Kirk's turn next.
Oh my god.
Well, he's older, isn't he? Isn't Shatner older than him?
I just find that
Well, at some point he will be.
Shatner.
Shatner's like 80 something, isn't he? And you look it up. I don't know. Look it up.
87, so we're just.
How old was Nemo?
I think it said 87.
Oh,
83.
okay, then
83.
83 for Nemo, and Shatner is.
Wow, Jared, on your phone in class?
It's okay. We're just checking. So did it say he died?
Yeah.
Really, like 92?
No.
Well, not okay, but.
I think it's 90.
Yeah.
Who?
Look who's on their phone now.
Now we're talking about
Oh, he does heavy
I
metal.
don't remember him for that.
Okay, determine ds by dt if s of t is equals using two different methods, right? So one method would be, hey, let's multiply it out, right? Just get ourselves, okay, let's multiply this out, get ourselves a, what are we going to end up with here? Probably 4 terms, right? So 12t cubed plus 6t squared minus 20t minus 10, right? That's s of t. So ds by dt will be what? Now you won't talk. All right, fine. 36t squared plus 12t minus 20.
Oh.
Yeah. Oh, the derivative. That's what we were doing. Yeah, sorry. I thought we were doing something else. Okay, so that's one way, right? You multiply out. The other way would be to use the product rule. So let's scooch this in down here. So what's it going to be? So ds by dt is going to be the first function, 3t squared minus 5, times the derivative with respect to t, so d by dt, of the second function, 4t plus 2, plus the second function, 4t plus 2, times the derivative with respect to t of the first function, 3t squared minus 5. Okay, so 3t squared minus 5 is just that. And this derivative is?
4.
Yeah, it's like hitting a golf ball. Plus 4t plus 2, and this derivative is, after the fifth t, what do you reach in golf? The sixth t. I know, bad golf puns.
Oh.
Oh.
All right, what do we got? So let's multiply it out. 12t squared minus 20 plus 24t squared plus 12t. So we've got 36t squared plus 12t minus 20. Would you look at that? Yeah, so doesn't seem to matter if you multiply it out and then take the derivative, or if you use the product rule to find the derivative. Well, yeah, but when it gets more complex than this, it's like how much multiplying out do you want to do? For example, dramatic effect, right? And then the smartboard doesn't work. If f of x is 3 minus 2 root x times 2x minus 5 root x, use the product rule to determine a simplified expression for f prime of x. So first, we want to get rid of root signs, right? So it's 3 minus 2x to the 1/2. Ah, really? I can't undo that, can I? I have to move it. Bracket. And 2x minus 5x to the 1/2. Right? I mean, if we're finding derivatives, we have to have exponents, not radicals, right? Okay, use the product rule. So f prime of x. It's the first function. 3 minus 2x to the 1/2 times the derivative of the second function. All right, so what is the derivative of the second function? 2 minus 5/2 x to the negative 1/2. Okay, so you should have had some practice yesterday doing the sum and difference stuff, and especially with rational exponents. Plus the second function, so 2x minus 5x to the 1/2, times the derivative of the first function, which is right, negative x to the negative 1/2. Okay, so yeah, calculus is really all about just practicing, practice, right? You just have to do enough so that when you're looking at that stuff, it just becomes, okay, so it's minus 2 times 1/2 is 1, and then x to the negative 1/2. Can't be thinking about sort of basic finding derivative stuff. Okay, so let's multiply this out. 3 times 2 is 6. Minus 15/2 x to the negative 1/2 minus 4 x to the 1/2 plus 5. Just plus 5, right? Because x to the 1/2 times x to the negative 1/2 will be x to the 0. Plus, okay, wait, we don't need that. Actually, we don't need a bracket on there either, do we? So minus, okay, what do we got? Minus 2x to the what? 1/2 plus what? It's going to be 5, right? Yeah, plus 5. Okay, so collecting stuff together. What do we got? Okay, so let's do it in powers of x. So we've got minus 6x to the 1/2 So let's did this and this. So minus 15 halves x to the negative a half. So we've got that. So now we got the numbers, right? So what do we got with the numbers? 6, 11, 16. Plus 16. All right? So to keep track of everything, I've just checked it off as I went through it, right? Just going through looking for like terms, going in descending powers of x. So it's negative 6 root x minus 15 over 2 root x plus 16. Okay, so just going back into radical. Now, determine the equation of the line tangent to y equals f of x at x equals 4. All right, so we need two things then, right? We need a point. So we need to know what f of 4 is. So we have the point 4 comma f of 4, whatever that is, we'll work that out. And we need the slope at that point, right? Or f prime of 4. Okay, so we need f of 4. So we need the point. We need the point. All right, so what's f of 4? So we just throw that in, right? It's going to be 3 minus 2 root 4. It's like somebody chose the numbers carefully. And then what do we got? 2 times 4, 2x, minus 5 root 4. Minus 5 root 4. Okay, so this is what? Negative 1. 3 minus, so 2 times 2 is 4. 3 minus 4, so that's negative 1. And that's 8 minus what? 10? So that's negative 2. So that's 2. Okay, so we have the point 4, 2. Okay, and we need the slope. Slope of the tangent. AKA f prime of 4, which is, okay, so negative 6 root 4 minus 15 over 2 root 4 plus 16. All right, let's drag this along the bottom. What do we got? Negative 12 minus, what's that, 15 over 4 plus 16. Okay, so we got 4 minus 15 over 4. That's a quarter then, right? Because 4 is 16 quarters. 16 quarters minus 15 quarters, 1 quarter. So slope. And then your favorite way of, mean point slope. Y minus y1 is m, x minus x1. Y minus 2 is 1 quarter, x minus 4. Y minus 2 is a quarter, x minus 1. What are we going to do? That's class. Y equals 1 quarter x plus 1. Okay, so we got 4x minus y. So multiply through by 4. So 4y, 4y, 1x. What am I? Hang on. Control Z. Yeah. Control Z. Okay, that's not going to work. I need a delicate eraser. Oh yeah, that was. Okay, what is it? Y is 1 quarter x plus 1. Okay, so 4y, 1x. So x minus 4y plus 4 equals 0. Okay, is that it? Yeah,
Sure.
good. So you got. Oh, I'll leave it out for a second. Okay, so the whole procedure is just using the product rule, to determine an expression for the slope, and then finding the tangent line, slope and point, and equation, and yeah, right? For the graph, determine the value of. So we got a graph in front of us, right? So it's showing us four things. It's showing us the graph of y equals f of x. We don't really know any of these equations, although I guess we could suss them out somehow, right? But it doesn't matter. We've got the graph of f of x in blue, or black. We have the graph of f prime of x in dashed blue or dashed black. And then we have the parabola, which would not really be easy to figure out the equation, right? But it doesn't matter. We're not actually figuring out the equation of any of these things, right? So we've got g of x, and then we've got g prime of x. So the first question is, what's f plus g prime of 1? So that's a sum, right? So what do we do for a sum of derivatives? Do the sum of the individual, right? So this is just going to be f prime of 1 plus g prime of 1. Okay, what's f prime of 1? Well, here's f prime of x, right? When x is 1, f prime of 1, sorry, is 2. So f prime of 1 is 2. When x is 1, g prime of 1 is, find it on yours, just you're looking for an x value of 1 and you're looking at the g prime curve. So when g prime of 1 is negative 1. So we have 2 plus negative 1, which is 1. So f plus g prime. Now, we're not doing this from equations, right? We're doing this from curves, right? We've got these curves, and okay, everything's good. So what's f minus g prime of 4? What do we have to figure out? Yeah, it's f prime minus g prime, right? So it's f prime of 4 minus g prime of 4. Okay, what's f prime of 4? 1. What's g prime of 4? 5. What's 1 minus 5? A number. Which hopefully we don't need a calculator, right? Negative 4. Okay, what's f g prime of 1? You can do that all at once, really?
Sure.
Oh, okay, because I figure I kind of got to use the product rule, right? Which says it's f of 1 times g prime of 1 plus g of 1 times f prime of 1.
Well, yeah, I did all
Oh,
that.
you did all that. Oh, okay.
I'm just an eager beaver.
All right, so what's f? Okay, so give us the numbers. What's f of 1?
4 times negative 1 plus negative 2 times 2.
4 times negative 1 plus negative 2 times 2. And where did that work out to? Negative 8.
4 minus 4.
Negative 4 minus 4, negative 8. Okay, cool. Well, that's how we do it, right? So we're looking, we've got this product, right? We want the derivative of a product. What do we have to use? The product rule. Okay, and then f g prime of 4, same deal, right? Got to use the product rule, but this time it's f of 4 times g prime of 4 plus g of 4 times f prime of 4. So, what are the numbers? F of 4, what's that? 8? F of 4, yeah, g prime of 4, so we're just looking along here, right? So g prime of 4 is 5, plus g of 4, g of 4 is 4, and f prime of 4 is 1. So what's that, 44? 44. So I almost thought there was another page, but I just had the duplicate page. So that's it, eh? We're done?
Yay.
I turned the pages.